I, together with my team, will discuss the infiltration-percolation process. It is a part of hydrologic cycle or best known as water cycle.
Ayan, bago natin bigyang kahulugan yung infiltration at percolation, alamin muna natin yung mga ilang impormasyon patungkol dito. Infiltration term, first used by an American geologist, Robert E. Horton in 1935 as he described the phenomena of soaking water into the soil. Ngayon, alamin naman natin kung ano yung kahulugan ng infiltration at percolation. Infiltration is the process by which water on the ground surface enters the soil, fast at the beginning and slow at later stages. Infiltration takes place at uppermost stratum of soil and movement is vertical. Percolation is the process of liquid slowly passing through the filter. Percolation comes from Latin word percolare, which means to strain through. Percolation happens at deeper depth when water moves vertically to join water table, usually slower compared to infiltration. So ayan, sa madaling sabi, yung infiltration, yun daw yung entry of water. At yung percolation naman, yun naman yung downward movement. Ngayon, paano sila nag-uugnay sa isa't isa? Hindi magkakaroon ng percolation kung walang infiltration. Dahil yung infiltration daw, yun yung pagpasok ng tubig sa mga open pores ng lupa. Ngayon, pag nagkaroon ng infiltration, dun palang magkakaroon ng percolation kasi wala namang bababang tubig kung walang pumasok na tubig sa lupa. Base sa obserbasyon, when percolation stops, infiltration also stops. Ba't nga ba sinabi yung gantong obserbasyon? Kaya hihinto yung infiltration pag huminto yung percolation dahil natapos na yung process ng pagpasok ng tubig sa mga open pores ng lupa. At base rin sa isang obserbasyon, when infiltration stop, percolation is continue. Ngayon, hindi ito katulad ng kabaligtaran ng isa. Kasi, kaya magpapatuloy yung percolation pag huminto yung infiltration kasi hindi pa siya magkakaroon ng percolation kagad. Kumbaga, pag nag-start pa lang yung infiltration, dun pa lang mag-i-start yung percolation. Kaya kapag napasok na ng tubig, yung mga open pores, huminto man yung pagpasok ng tubig dun dahil halimbawa napasok na lahat ng open pores, dun pa lang mag-i-start yung percolation. Kasi diba, ang sabi nga dito, yun yung downward movement of water na magjo-join dun sa may water table. So, and ito lang yung figure. Isa inflow. Yung sa may inflow na yan, yun nga, bigyan na lang din natin ng pakahulugan. Yung inflow, siya yung parang pinaka-source ng tubig. Pwede siyang precipitation, pwede sa mga groundwater, mga ganun. Tapos ito, yung sa maaraw sa baba, yun yung parang kinoconsider natin na pinaka-open force ng lupa na dadaanan ng tubig. So yan, distribution of soil moisture. Dito yung sinasabi natin na parang bawat layer ng lupa. Dito yung number 1, saturation zone, 2, transition zone, 3, transmission zone, and 4, wetting zone.
Factors affecting infiltration. 1. Vegetation cover. Defines the percentage of soil which is covered by green vegetation. How does it affect infiltration? Vegetation cover of the land impacts the infiltration capacity. Vegetative cover can lead to more interception of precipitation, which can decrease intensity, leading to less runoff and more interception. Increased abundance of vegetation also leads to higher levels of evapotranspiration, which can decrease the amount of infiltration rate. Debris from infiltration, such as leaf cover, can also increase infiltration rate by protecting the soil from intense precipitation events. 2. Moisture content or the water content. It is the quantity of water contained in a material such as soil or the soil moisture, rock, ceramics, crops, or wood. This also affects infiltration. Soil that already saturated has no more capacity to hold more water. Therefore, infiltration capacity has been reached and the rate cannot increase past at this point. This leads to much more surface runoff. When soil is partially saturated, then infiltration can occur at a moderate rate and fully unsaturated soil have the highest infiltration capacity. 3. Temperature. As the temperature increases, the rate of infiltration also increases, and the temperature decreases, the rate of infiltration also decreases. 4. Intensity of rainfall. It is a measure of the amount of rain that fall over time. However, if the rainfall intensity is smaller than the saturated water permeability of the soil, the infiltration capacity of the soil is larger than the rainfall intensity. All the water infiltrate the soil and no accumulation or excess of water appears on the surface, maintaining the slope surface unsaturated. 5. Human activity. One of the human activities is the agriculture and it is one of the factors affecting infiltration. Agriculture has been the cause of significant modification of landscape throughout the world. Tillage of land changes the infiltration and runoff characteristics of the land surface, which affects recharge to the groundwater, delivery of water and sediment surface water bodies, and evapotranspiration.
Quality of water. Silt and other impurities in water resulting in reduction of infiltration. 7. Movement of man and animals. Heavy movements causes compaction of soil result in less infiltration. 8. Presence of groundwater table. If groundwater table is near to the earth's surface, it reduces infiltration. For infiltration to continue, groundwater table should not very close. 9. Size and characteristic of soil particles. Infiltration is directly proportional to the grain size or diameter for the granular soils. However, if the soil is swelling minerals like little and normotronite, the infiltration rate will reduce drastically. Measurements of infiltration. The measurement of infiltration of water into the soil is important indication concerning 1. The efficiency of irrigation and drainage. 2. Optimizing the availability of water for plants. And 3. Improving the yields of crops and minimizing erosion.
Measurement of infiltration. Field measurement of infiltrometer is done by the instruments known as infiltrometers. 1. Single ring infiltrometer. 2. Double ring infiltrometer. 3. Tension infiltrometer. Next. First infiltrometer. Single ring infiltrometer. Infiltrated water spreads out in outer adjoining area leading to overestimation. Next. Double ring infiltrometers. The outer ring provides water jacket to the infiltrating water from the inner ring and hence prevents the spreading out of the infiltrating water from the inner ring. Yung pagkakaiba lang ng single tsaka double. Yung sa single kasi, ito yung sa transient land or ito yung mga lupa na dating dry land or wetland. Sa paggamit naman ng double, ito ginagamit sa mga transient state or steady state land. Ito yung mga paiba-iba ng texture ng lupa. Ganon. Tension infiltrometer, it measures the hydraulic properties of unsaturated soil. Water held under tension infiltrates into a dry soil through a highly permeable nylon member. Yung tension filter ginagamit to para malaman kung may differential lupa, kung pwede siya magkaroon ng sinkhole, wormhole, ganun.
Measurement of infiltration rate. Infiltration rate is the velocity or speed which enters into the soil surface. Ang infiltration rate, ang small f of t, it is usually measured by inches per hour or cm per hour. Cumulative infiltration, capital F of t, cumulative depth of water infiltrating during given time period. Ito siya, ang capital F of t is equal to integration from 0 to t of small letter f of t dt. Dito mo madiderive mo ang formula na infiltration rate na small f of t is equals to df over dt. Ang infiltration rate lumiliit habang tumatagal kasi nagiging saturated ang soil. Capacity of infiltration, the volume of water that the ground or soil can hold. Dahil nga habang nagiging saturated ang lupa, lumilit ang infiltration rate, madalas ang sobrang tubig nagiging runoff at hindi na nahihigop ng lupa. Filtration capacity, the maximum rate at which water can enter soil in a given condition. Ang infiltration capacity ay na maximum rate na nahihigop ng lupa. Depende kung ano ang initial condition ng soil. Ang F is infiltration capacity, FA is actual rate of infiltration, and I is intensity of rainfall. Note that FA is equals to F when intensity of rainfall is greater than or equal to F. Ibig sabihin, pag ang infiltration capacity is equals to or less than rate of rainfall, ang actual infiltration is equals to infiltration capacity. Kasi yung sobra niyan nagiging runoff. FA is equals to I when intensity of rainfall is less than F. Kapag ang intensity of rainfall less than infiltration of capacity, ang actual rate of infiltration is intensity of rainfall. Ibig sabihin, ang gaano karaming ulan, ang rate ng ulan ay na ang infiltration rate kasi na-absorb niya lahat.
Infiltration index is the average infiltration rate. There are two commonly used infiltration indices, the pi index and W index. Indices are extremely used for the analysis of major floods when the soil is wet and the infiltration rate becomes constant. Pi index is the rate of infiltration exceeding which the volume of rainfall becomes equal to runoff volume. It can be used to estimate surface runoff from a given hydrograph, especially useful for predicting the infiltration from a storm occurring over a very large basin, and it is also useful for the unit hydrograph analysis to determine the pattern of rainfall excess. The formula used for pi index is the total rainfall minus the total runoff over time period for rainfall excess. W index is more accurate than the pi index because the interception and depression losses, which are considered as part of infiltration. Thus, W index is always less than the pi index The formula used for W index is equal to total rainfall minus total runoff minus total losses all over the total time period. And that's the end of our presentation. Thank you for listening.